Please title these notes Graphs 5 Notes using your calculator and write today's date.
By the end of this lesson, you should be able to use your calculator to find maxima and minima, inflection points, increasing, decreasing, and concavity for functions for whom you're giving the equation, but not the graph. So the idea with this is that sometimes you're given an equation instead of a graph. If you're in the calculator section, grab your calculator. The calculator is your best friend. Really, it is. A couple of really key notes about it though, because it can stab you in the back if you're not careful. Put it in radians. Always set your x-min and x-max. This is under the window to the interval given. Always zoom in on any part of the curve that is close to the x-axis. To see if there are more zeros than you see at first. So let's give an example.
Please title.
The derivative of f of x is given by f prime of x equals e to the sine x minus 2. First question, how many critical values does f of x have on the interval -10 is less than x is less than 10. Couple of key things to notice about this question. Critical values simply mean that f prime of x equals 0 or undefined. These are the potential maxima and minima. Basically, they're where we're going to look to see if there's a maximum or minimum, but we're not sure if there is. They have their own special name called critical values. So we're just looking for f prime of x and whether it's 0 or undefined. Also, these open less than signs mean that 10 and -10 can't be our answers. We're looking at the interval that does not include them. So the first thing we're going to do is just set up our justification. So f of x has however many critical points because f prime of x equals 0 or undefined that many times. That's what we're looking for. Now let's go to our calculator. We're going to go over to y equals and then we're going to enter in e, so that's second, and then the natural log button. Sine is right here. X is our variable there. Minus 2. Make sure you're in radian, so hit mode. That radian should be highlighted. If not, arrow down and then hit enter. Then go back to y equals. Okay, we have a window that is negative 10 to 10, so I'm going to go to window. I'm going to set my x min to negative 10, my x max to 10, and then let's just do the standard negative 10 to 10 for y as well and graph it. Okay, so what I can see right here is that there's 1, 2, 3, 4, 5, 6 places where the curve crosses the x-axis. I'm not 100% sure what's going on right over here, so what I'm going to do is I'm going to go to my window. Let's say that's right about where x equals negative 10. So I'm going to go from negative 10 to negative 9. Let's zoom in our y a little bit. Let's do like negative 1 to 1. I'm going to see if there's another one right there over on the edge of the graph. Looks like it's not. There's still a pretty good gap there. So that means we only have 6 critical points. Next, we wanted to know how many relative minima. Let's go back. If we hit zoom 6, it takes us back to that original window. So first what we're looking for is f of x has blank relative minima because f prime of x, a relative minima, means f prime of x changes from negative to positive. So specifically from negative to positive happens once there, twice, 3 times. So 3 relative minima. For our next one, let's go for how many inflection points. I'm going to say f of x has blank number of inflection points because f prime of x, and if we remember our chart, inflection points happen when f prime of x changes from increasing to decreasing, or vice versa, that many times. So if we look here, we can clearly see there's 1 decreasing to increasing, 2, 3, 4, 5, 6. What's not clear is what's happening right here. Is there another inflection point here before we get to 10 or not? So let's zoom in again. We're going to go, let's say, from 9 to 10, and let's make our y zoomed in as well. Oops, looks like we need to zoom out a little bit for y. Looks like it just keeps going down. So we just had those 6 that we saw earlier. For our second problem, the derivative of f of x is given by f prime of x equals negative 0.1 x to the fourth plus 0.5 x cubed plus 0.1 x squared minus 0.5 x. And we want to know what are the x coordinates of any critical points on the interval -3 is less than x is less than 6. So we're going to go to our calculator, we're going to enter it in. Remember the exponent is that little caret button right there. We're going to go to our window, set it to -3 to 6 for x, and graph it. Okay, critical values are values where f prime of x is 0 or undefined. So what we want to find is we find the actual number for x at this point right here where we see that f prime of x equals 0. So what we're going to do is we're going to go to second, and then calculate. We're going to look for 0. If you have a TI-82, this says root. And then what we're going to do is we're going to go over until we're just a little bit to the left of the point that we want. If you want to move faster, you can do second and then the left to right arrow. So once we get a little bit to the left, we're going to hit enter, telling it to start looking for a 0 there. Go a little bit past the 0, hit enter to tell it to stop looking there, and then hit enter one more time. So x equals 5 is one of our zeros. So we're going to say the x coordinates of the critical points of f of x are x equals 5. Then we're going to have some more because this is where f prime of x equals 0. So let's find the rest. Right over here, this is where it's really important to zoom in because we can't quite tell what's going on here. So if we just hit zoom and then 2, that'll actually zoom us in once we hit enter. Unfortunately, sometimes it doesn't zoom us where we want it to be, so let's go back, zoom 6. Now once it redraws us, zoom in, there we go. Okay. Here we see 3 more places where f prime of x equals 0. Let's go ahead, do the second calculate 0 for each of them. We actually see one of them here without even having to calculate it. It's x equals 0. So we've got 5, we've got 0. Let's get this one over here. We go over a little bit past it. To the left. Hit enter to tell it to start looking. Enter to tell it to stop looking. Enter a third time to guess. One of our zeros is -1. And then we repeat to find the final 0. Again, second arrow moves it faster. Start looking there. Stop looking there. I'm just hitting enter. Tell it to start and stop. Enter a third time. And +1. There we are. For part B, what are the x coordinates of any points of inflection on this interval? And so to answer that, we remember what the inflection points are. So the x coordinates of inflection points are x equals, and we'll fill that in, because this is where f prime of x, remember from our chart, inflection points for f of x come when f prime of x changes from increasing to decreasing, or vice versa. So if we come back to our graph, we see an increasing to decreasing right here. The way that we find that is to go to second, calculate, but now instead of finding a 0, we want to find the maximum, because the maximum is where we have that change from increasing to decreasing. So we'll start off again just going a little bit to the left of the maximum that we want to find, because there's our maximum, so we'll start a little bit to the left. Then we'll go past it a little bit to the right, hit enter a third time to guess, and it gives us a maximum value of negative 0.597. Use 3 places after the decimal for the AP test. Let's do that again over here, but now instead of looking for a maximum, we're looking at a minimum where it goes from decreasing to increasing. So second calc 3 is a minimum. I'm going to start a little bit to the right side of the point that we want. Go past it, hit enter a third time. 0.552. Now, we have to remember that we zoomed in for this. So to check that we make sure that we've gotten them all, we should really go put our window back to this original interval that we wanted, -3 and 6, and just to make sure that we got all of them. So we got 1, we got 2. Oh, looks like there's a third one up there. Let's zoom out our y, so let's make this like -5 and 5 and see if we can see our other maximum. Still can't, so let's go back to this. Let's make that y maximum 10. Now we can't see these relative maximum and minima very well anymore, but now we can see this one, so we need that for our final one. Second calculate, that one's a maximum, so that's 4. Okay, we're a little bit to the left of the maximum, a little bit to the right, enter a third time, 3.795. Okay, let's do a last few notes just right down here on the instructions. First we got to graph it, then we go to second, trace, and 0, or minimum, or maximum. All depends on what we look for. Use the arrow keys to get slightly to the left. Of the point you want. Hit enter. Use the arrow keys get slightly to the right of the point you want. hit enter, and then remember to hit enter a third time. Okay, that concludes Graph 6 Notes.